I listen to many people talk about African horse sickness, a lot of them with a lot of confidence, and a lot of them have many misconceptions that result in misinformation when information is transferred over social media. So when I monitor these social media sites, and not in a creepy way, now and then I comment, and I really appreciate Mariki Fenter's drive and motivation to explain things from a scientific basis, which gets ignored completely, and I really am sorry about that. But I think we need to start understanding, as scientists and as a veterinarian, that we deal with lay people on many occasions. The misunderstandings come from the way that we package messages. And sometimes I think we get bogged down in science, not understanding that our messages need to be packaged for lay people. And if lay people are not understanding what we are saying to act or comply on African horse sickness control, then we should change our messages. So that's what I'm going to attempt to do. I think we sometimes forget that we in South Africa are unique in a global situation where we have African horse sickness on this continent. And actually, I know we don't think that we control African horse sickness really well, but the rest of the world thinks that we're doing a great job because it very rarely goes out of the African continent. Okay, even though it has in Spain and Portugal and in areas in the Middle East and India, but still, because it hasn't spread further than that and there haven't been many outbreaks, I think we're doing a great job. However, there's always more work that can be done. So generally, the control and eradication campaigns for African horse sickness require us to prevent the spread of the virus by the biological vector, okay, which is the midge. So international control measures include the slaughter-out policies, which we don't have in South Africa because it's an endemic disease. Okay, so obviously, if we had to control African horse sickness completely, there are things that we need to eradicate. We either eradicate the horse, we eradicate the virus, or we eradicate the midge. Unfortunately, we can't do either of them. Okay, so what we try and do is come to a moderate area where we look at the horse, we look at the midge, and we look at the virus, and look at things that reduce the risk of spread between the three. Okay, so vaccination has been shown to play a key role in the eradication of African horse sickness that has occurred outside of our country. And the way we use vaccines, we need to understand that vaccines are never 100% protective. And we need to understand that midge control and understanding the virus helps us and assists us in allowing the vaccine to work as much as possible. Also, when we are looking at horses, just like we look at ourselves as individuals, you cannot look at a horse and determine how that horse is going to respond to a vaccine, or how much of immunity that horse is going to develop when vaccinated. Neither are we able to tell how long that vaccine is going to last after vaccination or after boosting. Okay, when clinical trials are done on vaccine development, and this is really interesting, and I never knew this as a veterinarian, and only when I worked in vaccine development, I understand why certain recommendations are given for vaccine use in countries, especially with different types of vaccines. Many of the control trials that are done on vaccine development is based on regulatory requirements. And the reason we have to vaccinate with African horse sickness every year is because usually the regulatory requirements requires the drug companies to only research the product and document its results based over a year or a 14 to 16 month period. Okay, so OBP or these drug companies can only guarantee that time period, even though immunity may last over that period of time. And the only way that we'll know whether immunity is longer than the recommended period is if we do neutralizing antibody titers, which is not done routinely in South Africa at the moment. Okay? Even our rabies titers that we do on animals as well as humans are sent to Herbright Institute in the UK for antibody titer testing. Okay, so it's these things that we need to understand when we're talking about horse sickness control. And I think when we are talking about vaccines, we start off with the premise that vaccines are not 100% effective. Okay? And when we are doing vaccine development, and Dr. Meyer spoke about how difficult it is to do these trials, and all the paperwork and legal requirements that are needed for this vaccine development to take place, we need to understand that these vaccines sometimes take 10 to 15 years to come to the market, okay, which is a long time, which is why it's really nice to have many projects happening in different time phases so that these vaccines don't come out 1 year or 2 years after each other. There are a huge number of anti-vaxxers globally currently, and not just for human vaccinations, but it's a growing trend with animal vaccinations currently, and there are big issues with zoonotic diseases where people are refusing to vaccinate their animals, which means that zoonotic diseases in human populations become a bigger and bigger concern. Okay? When we are defining protection, we never, ever put on a bottle what that level of protection is. Yes, it does need to be greater than 70%. And what does that mean from a regulatory point of view? It means that when we are developing vaccines, we take a statistical number of animals, which is sometimes not truly representative of an entire South African horse population. We then take blood samples and see where their antibody titers are or where their levels of exposure to a virus is. We then vaccinate them, okay, allow them to develop an immune response, and then we challenge them with a live virus. And the way we determine protection is by how many of those horses show specific signs to that challenge. So generally, if your animal's not showing clinical signs to that challenge, it means your vaccine has been protective. Okay? Obviously, never 100% of those horses are protected. There are some horses that show clinical signs, and sometimes there's horses that even die. So when we're talking about protection, that's what we're talking about. And from a veterinarian point of view, I think often when we talk about protection, a lot of lay people think that we are talking about 100%. Okay, so that's where the misconception comes in. Dr. Meyers and Dr. Trenter have spoken about neutralizing antibodies. Neutralizing antibodies are those antibodies that neutralize the virus and prevent it from entering into cells to replicate, to cause damage, and to cause release of the virus into the rest of the body. Okay? And the efficiency of that neutralizing body antibody production depends on many factors, okay, including vaccination and natural immunity. There are also non-neutralizing antibodies that coat the virus, especially when the virus is being cleaved, that doesn't specifically identify the virus to the body, but it helps the body identify the virus as soon as neutralizing antibodies come into play. So the non-neutralizing antibodies are really helpful because it actually stops the virus from being infected as well, okay, but doesn't neutralize it completely. So when we are talking about African horse sickness or any diseases, there's always a triad of things that have to happen for diseases to occur. You always have the susceptible host, which is the horse. You have a conducive environment for that horse to contract the disease, which is the midge. And Gert, I'm so sorry if that's not Imicola or Latino.
I think it's no.
I just pushed it off the internet. Okay. And then you have the actual pathogen, which is the virus, which goes through the midge into the horse. When we are looking at targets for control, what we are trying to do is look at these three things to lower our risk of these animals getting diseases, or even if the animal has the disease, to lower the risk of spread to other animals. So when we talk about vaccines, what do we talk about when we talk about acceptability of these vaccines for production? We're looking for a safe, efficacious, and freely available vaccine. Okay, so at times of outbreaks, or even times where you have recommendations for vaccinations, we want those vaccines to be available, and available for all horses that require those vaccines. Okay? These vaccines should not cause disease or viremias, because again, if these vaccines cause viremias, they can be picked up by midges and transmitted to other animals. And also there's the reassortment issue. It should not revert to a virulent virus, which means that these vaccines need to be as safe as possible and not cause disease in these horses when they are injected. They should protect against death and clinical signs. So what these vaccines actually do is they do prevent your animal from getting disease, but if your animal has that disease anyway, it reduces the severity of the clinical signs of that disease. Okay? They should be readily available. They should be thermostable. So thermostability is quite important because this affects how vaccines are stored. Okay? So the more thermostable your vaccine is, the better it is for transporting and cold chain management, and the fact that you don't really need a refrigerator to keep these vaccines for storage, which means that we can prolong their shelf lives. And often, if you prolong their shelf life, that means that these vaccines become more readily available. What you need from these vaccines, besides the whole development of these vaccines and the type of immune responses that they elicit in horses, we need to have a system where we can bank and cryopreserve stock so that in the advent of an outbreak, these vaccines are, or these vaccine candidates are freely available for them to be put into production immediately. Okay, so we call them seed stock. Okay, it's like a protected stock of these vaccine candidates that we then use for production, because production for African horse sickness doesn't happen the entire year. And obviously, it's to our benefit if we have the DEBA vaccines, and like Dr. Mayer said, we want to differentiate between a vaccinated horse and a field outbreak. Okay, and it's important not just for us to know as veterinarians, but for international trade or movement of horses, it's always good to know whether the vaccine elicited a response or if it was a field strain. So when we talk about live attenuated vaccines, and I was fortunate enough when I worked at the ARC to do a vaccine development project with Lorne Baberick. He's a well-renowned livestock vaccinologist, and I had a really interesting discussion with him because we were developing a pox-vectored vaccine that carried 5 livestock diseases on 1 vector, which was quite a tricky vaccine to develop, and it's still not in any great stage of development. But the interesting thing that he said to me was that, Threshni, you're not going to get a better vaccine than a live attenuated vaccine. And I said to him, but there's so many disadvantages to them, and there's no place in it in international trade anymore. And he said to me, the reality with the modified or the live attenuated vaccines is that when the virus is actually being cleaved by the body, after it's being neutralized, is that the body, as the vaccine is broken down, it makes further antibodies to the inner parts of the virus, which makes it a lot more efficient for the body to recognize the virus as foreign, to remove it from the system as quickly as possible. Okay? So the more antibodies, specific or non-specific, to a live attenuated vaccine, the better it is to be evacuated from the body. What we sometimes forget about live attenuated vaccines is that when these vaccines are made, they are passaged through cells. And they are passaged through many cells, and as they move through these cells and replicate, they become weaker and weaker. Okay, and that's how we attenuate or weaken these viruses. You still want the virus to replicate, because when the virus is injected by the midge into the horse's body, that virus can't just sit there because you just have a local response. You don't have a generalized immune response to that vaccine. So what you wanted to do is you wanted it to go into the peripheral blood vessels. In those peripheral blood vessels, there are cells that line those blood vessels called endothelial cells. The virus should be strong enough to penetrate into that endothelial cell, replicate to a much lower extent than a natural virus, and it will burst through that cell and then go and be taken into the body where it gets to the spleen and is filtered by the spleen. Okay? In that process, it's triggering a massive immune response that the body either remembers or not. Okay? So that's how you stimulate the immune system. And often with vaccinations, you have two responses. You have the actual inflammatory response from the needle injecting through the skin, okay? And then you have the actual immune response to the antigen, which is the vaccine virus that goes into the body. So you find that the inflammatory response actually encourages that immune response and the localization of white blood cells into that area to allow that efficient immune response to the vaccine initially. Okay, so with the live attenuated vaccines, you do want them to replicate, but not to the extent of a live or natural strain. Usually, these live attenuated viruses do not cause disease. Okay, and I know there are many cases where, and this is why the new vaccination recommendations have come into play, is that when you do have midge activity, besides the reassortment and reversion to virulence, I think we have to remember that the midge activity, especially early on in the season, you'll find that you have low doses of African horse sickness being injected into these horses. However, if you don't monitor your horse very carefully, you'll find that the vaccine, if you vaccinate at that point in time, it overloads the immune system and you will get clinical signs. So when vets come out and ask you, have your horses been eating and drinking, and ask you a whole load of other questions, it's really not an inconvenience. We actually want to find things that signal us in our minds to say that maybe we shouldn't vaccinate now. Okay, so it's really important for owners to give us that information truthfully and not take it as an inconvenience, or actually my horse really has to show on Monday, it needs this vaccination. Okay, so again, it's about reducing your animal's risk for disease. I think the most important thing for me over the past 3 years has been how fragile that virus is as a freeze-dried vaccine in that vial, and how it's transported and stored before it's vaccinated. And the interesting thing is that even though the vaccine is freeze-dried, people always think, oh, it's been freeze-dried, I can keep it in the freezer. No, you can't. It actually it actually weakens the vaccines in the vial, and it also produces a poor response when you are vaccinating. Which is why the recommendation is that you buy your vaccine from the vet and you get the vet out to vaccinate. And there's a reason for this, is because usually veterinarians get their vaccine supplies from distributors. So a lot of owners who buy their vaccines from a co-op, usually it's gone from OBP to a distributor, to a co-op, to the to your stables. And the problem with that is that every time there is a delivery to a new place or the vaccine has been taken out of the fridge, there is a cold chain issue that affects the vaccine and how it works. Okay, I have seen clients that have vaccines stored in their fridges, especially the old fridges that frost. So you'll be pulling the vaccine out of the bottom of that caked in ice, pulling it out. Okay, I've also seen owners who have mixed their freeze-dried vaccine with saline or sterile water. Please remember that the vial, the liquid vial that it comes with, is actually phosphated buffer solution, and it's a buffer that buffers changes in pHs when the vaccine is being mixed. Okay, so these little things actually affect the way these vaccines stimulate an immune response. And I think sometimes we don't consider that, because a lot of owners tell me it's cheaper to buy the vaccine from the co-op and have the vet come to vaccinate the horse. But the reality is that veterinarians are held responsible by the South African Veterinary Council, because the new requirement for our vaccine storage is to have min-max thermometers. And the min-max thermometers ensures, and is part of a quality assurance system that ensures that when veterinarians are buying and storing vaccines, that it's maintained between 2 and 8 degrees Celsius. Okay. How many of you know whether your fridges are maintaining your vaccines between 2 and 8 degrees Celsius? How many of you also store your vaccines on the door of the fridge? Don't be shy, put your hands up. Come on. You won't tell. Okay, the problem with placing your vaccines on the door is the one that opens and closes, and you'll find that the recommendations for by fridge manufacturers is that you keep things like eggs and sauces on those shelves. It's because that part of the fridge is a lot warmer than the rest of the internal part of the fridge. And also where you store your vaccines in the fridge is of critical importance, because you should be storing it in the middle shelves, not in the lower shelves, because the lower part of the fridge is actually a lot colder than the upper part of the fridge, which is why you store your vegetables at the bottom. Never mind. Okay, so I think sometimes we don't take those little things into consideration. I think the other thing that we need to understand is that if your animal has passive immunity, or if your animal has low doses of virus that's been injected by midges that you're not aware of because you can't see it and you can't see the midge either, you have to realize that the body is producing antibodies that do have an effect on the vaccine when it's injected, because it is a live attenuated vaccine. Okay, so those little responses reduce the working of the vaccine. So if you look at the African horse sickness virus structure, and both Mariki Fenter and Dr. Mayers have spoken about this, we're looking at different layers of this virus. So you have its 3p2 and all these different proteins. All these proteins, as they are cleaved by the body's immune system, all stimulate an immune response to the virus or the vaccine. Even these nucleic acids stimulate, it's not a specific response, but they still stimulate an immune response. So every layer, as that virus is cleaved, allows for a better, efficient response when your body is evacuating this virus from the body. So dead vaccines, the dead vaccine that's currently available in South Africa is the DCA vaccine. The DCA vaccine is registered under Act 36 of the Stock Remedy and Farm and Fertilizers Act. The vaccine is available under the prescription of a veterinarian. It is what we call, and the reason it needs a vet prescription, not because it's a better vaccine, it's because it's an autologous vaccine, which means that it has been used in outbreaks in certain parts of the country, but it's not truly representative of the larger parts of the country where African horse sickness is affected. Okay, so it is a registered vaccine, and because its cover is very narrow, a vet's prescription is required because the vet has to take a blood sample and make sure that that circulating strain is there before you have a reason to vaccinate. Okay. So I'm not saying it doesn't work, because dead vaccines do work. They're just inactivated, and they are produced again by growing the virus in the media, and then you inactivate the entire virus using either heat or chemicals. And the chemicals that are normally used is formalin. Okay, so when these vaccines are inactivated, the formalin actually changes the protein nature or the protein structure of some of those viral proteins. Okay, so sometimes the body doesn't truly recognize it as an African horse sickness virus, which means that this virus is also cleaved like a live attenuated virus, but sometimes the proteins aren't specific to an African horse sickness virus, which makes it slightly less efficient when trying to evacuate it from the body. Because they're dead vaccines, they're dead, they're not alive, they cannot replicate, and they cannot even cause disease even if you inject it into an immune-compromised animal. Okay. They are less affected by circulating antibodies, so if you have passive immunity, like a foal that has drunk colostrum, or a foal that has just been born from a mother that has been vaccinated, you'll find that it's less likely to neutralize the vaccine, which is not a bad thing. So it can be given when you have foals that are between 4 to 6 weeks old, without causing too much of a problem. These dead vaccines, we find, always require multiple doses to produce the same peak of immunity than the live attenuated vaccine. The live attenuated vaccine, the OV3 vaccine, usually takes 2 doses for you to get that peak immunity. But with the dead vaccine, it's usually protective after 2 to 3 doses. How many of you have used DCA? Not personally, but how many boosters did you get? 2. Okay. The immune responses are usually humoral, so you get a massive amount of antibodies that are produced, and they have little or no cellular immunity. So the antigens are not really presented on the cells for proper identification and evacuation by the immune system. And we find that with the dead vaccines that these antibodies actually diminish with time, so it requires more frequent boosting. And again, because we don't routinely do these antibody titer testings, it's really difficult for us to predict when exactly this the periodic timing has to happen. So not an easy task for dead vaccines.